Lecture 13, set 2, unsigned integers. We're just going to do a brief representation of this. The non-negative, if we have unsigned integers, that means that, we are only talking about non-negative numbers. And this includes 0 because, even if you have numbers that are inherently non-negative, like, time, we don't represent time with a negative number, but we have a notion of 0. And some other things like position and sometimes even temperature in the Kelvin are shown by non-negative numbers. And counting is also done with non-negative table indices. So these are actually important, and these are coded using unsigned binary or in base 2. And as you know, all numbers in the computers that we use today are in 0-1 format. So this is a Radix 2, which I'm sure you guys are familiar with, that you have seen in your logic design course. And this is basically a positional system that goes with the power of 2 at each position, and there are only 2 possibilities. And you, because we normally do computation in base 10, you may want to have that conversion in mind when you talk about these systems. And in the system, if you have n bits, you would be able to represent 2 to the power n minus 1 is the largest number we could represent. And basically, for representing n numbers, we need log of n in base 2 bits. So if we have 8-bit bytes, which is like the case for a very old microcontroller, it could represent numbers from 0 to 256. Then 32-bit words, we could represent up to 4 billion, and 64-bit words, we could represent unto 2 to the power 64 minus 1 bits. And here, we could apply arithmetic operations. We could, for example, see what a position is if we kind of go forward and backward. And we could also use this for select signals and other signals that have non-negative values. And then, because it's always, definitely when you write programs or when you write text, it may not be easy to write this train of zeros or ones. You could also compress that further. You could actually put 3 bits in one pack and then show the number in a base 8, or have 4 packs of 4 and show this in a base 16, which is very common, which is called the hex base. And then we also use, of course, numbers in the base 16. We should have 16 characters, so we use numbers from 0 to 9, but also A to F, and we have symbols assigned to them. And now, if we are doing, n-bit number, and we want to put it in an n-bit value, because these are unsigned, it's super easy. You have, say, you have written 7 in a 3-bit system, and you want to convert this to a 4-bit system. So all we do is we add 1 bit and we put a 0 there. So if you're trying to, in this example, say we have 8 bits and we want to assign this to 16-bit registers, we're going to transfer this 8 least significant bits, and the most significant bits are assigned to be 0 in this case. And then for truncating, we also discard the leftmost bits. And if the leftmost bits are 0, then the value is retained. But if they're not, then tough luck, we may get into some computational errors. So you have to be very careful when you're doing this. In the next set, we're going to talk about unsigned addition of these numbers.